actually. Okay. All right, let's do unit circle for special triangles first. Thank you. Do I need to prove these for you? Maybe I'll prove these for you. Let's prove these for you. Good? Absolutely. Yes. Okay, sorry to destroy your notes here. This is the pi by 4, pi by 4, pi by 2 triangle. Okay, please note in calculus you will only be working in radians. That's all you will be using. You will never use degree for any question. If a question is given to you in degrees, switch it over immediately to radians. Because when we talk about slope and derivatives and all that stuff, you can only do the derivatives with radians. Okay? And remember from grade 11 how to prove that 45, I mean pi by 4, pi by 4, pi by 2 triangle. And remember from grade 11. Yeah, so this is one we're going to take a square. This is a square and switch it in half. Why would I want to use a square? All sides are each other, yes. When you cut it in half, what is the angle going to turn into? 45, right? So what's it going to do? I'm going to chop it in half. This is how I always remember this ever since I was a kid. The triangle is going to turn into pi by 4, pi by 4 in right angle. Okay, what are the side lengths going to be? Well, since the square, what do you know about these sides, John?
1, 1, root 2.
Yeah, just going 1, 1, root 2. Okay. 1, 1 because it's a square, the side's going to be the same. Do you need me to show you why this is root 2, or do you guys can handle that?
What does this grade 9 review?
Well, 9 to 12. Okay, so x squared equals 1 squared plus 1 squared. X squared equals 1 plus 1. X squared equals 2. X equals root 2. Okay, x equals, so there's your 45, 45, 90 triangle. Okay. So if I say sine of pi by 4, what will you instantly say? Oh goodness. Sine of pi by 4. 1 root 2, thank you. We're going to talk about capital in a second so we can figure out what every angle is. This is the pi by 6, pi by 3, pi by 2 triangle. Okay, how can you guarantee you have 60 degrees in a angle? How could you get a 60-degree angle from? Instantly, automatically, always. Michael? An equilateral triangle, wonderful. Your grade 11 teacher must be wonderful. That was me, sorry. An equilateral triangle, if you remember, has 3 even sides and 3 even angles. How am I going to turn that into a 30, 60, 90 triangle? Right down the middle. Okay? Now, this is what gets people. So my angles, I'll try and draw here. Here's pi by 3. Here's a right angle. Here's pi by 6. For the side lengths, on the equilateral triangle, what does it make sense to have each side being? 2. Why, Matt? Yeah. Right. If you make every side here 2, when you cut it in half, that's now going to be 1. So everyone see that, right? 2, 2, 2, 1, 1, 1. Leftover side I'm going to call x. Since this is grade 9 review, I'm going to say that 2 squared equals x squared plus 1 squared. 4 equals x squared plus 1. 3 equals x squared. X equals 3. Okay. You need to know that triangle very badly. Other things you need to know from trig is lots. We're going to talk about Cast rule, solving equations. I'm going to talk about unit circle. I'm going to talk about a few of the identities, a few of the major ones you need to know. Just slowly come backwards, but I'm going to stop at. And I think we're stopping here. That's the name right now. What's what are they? Figuring is giant. This is a lot of documents, so I wouldn't lose him. You know that. Okay. Let's go to other things you should know here. Let's talk about I'm going to do the cast rule. Okay, Brandon, do you remember what the cast rule is all about? Okay, you're not quite done yet. Brandon, but you're close to being done. What does the A actually mean? All are positive. So all are positive. If you need me to write it out, that means sine theta is positive, cos theta is positive, and tan theta is positive. Good. Caitlin, can you tell me what the S stands for, please? Very good. So sine theta is positive? I can't really write. Good. How to Matt? Do you remember what the T means, please?
Tangent theta is positive.
Yeah, and everything else is negative, so I'm going to say sine theta is negative. Cos theta is negative. Tan theta is positive. Just for anybody here, not just Matt, what does tan mean on the unit circle? Do you guys remember? Like sine means something, cos means something, tan means something. Do you remember what those are? Good. Tan is sine over cos. I got that in a sec. What does tan go? What does tan represent? And this is really important for calculus. What's tan? Yes, good. Tan was your slope, right? Tan was your slope. Okay, so and calculus is about slope. We'll talk about that, right? But tan is slope. And if you take a look, you'll have a positive slope in this quadrant, right? You'll also have a positive slope in that quadrant. If you remember, sine is actually going to be your y values. So the y values are positive up here. The y values are negative down here. Cos is your x values. X values are positive. X values are negative. Okay? Just remember the cast rule, though. That's probably easiest for people. So sine theta is negative. Cos theta is positive. And tan theta is negative. We're going to use the cast rule to solve some equations in a sec. I just want to get the rest of the terminology down, if I could. Let's do a little bit of Pythagorean identities here. These will be quick ones. Do you remember any identities by any chance? If I talked about what 1 would equal, what does 1 the same as? Thank you very much. Sine squared theta plus cos squared theta equals 1. That's a Pythagorean identity. Okay. It's your first day. You know what tan is the same as? Right? Very good. Sine theta plus sine. What is sine of x plus y? This goes for anybody here. Remember this? Okay, go ahead. I believe that's right. I don't have this written down, actually. Is that right? That looks right to me. Okay, from that, what is sine of 2x equal to? Because this one we use a lot. Keep going, Megan. Yeah. Now, I'm going to slow down here because I'm starting to speed up. How do I get that other than memory? Yeah, break down to x. The ones I'm putting on the board are ones you're probably going to need to use in this course. All right. Sine of x minus y. Anybody here? Johnny got it? Yes, it is. Okay, let's go for cos x plus y. Yeah, I can't believe I'm gonna pause this so the internet doesn't need to see me struggle.